Hello all and welcome back. So in this video, let us now continue our discussion and now let's discuss a question which you all have to do. And the question is as follows. So given a height, okay, we have to tell number of possible binary trees. So in this question, we will be provided with a height. Let's say initially the height is 1. Now we have to tell how many binary trees are possible with this given height. For example, for height 1, this is one binary tree which is possible. For height 2, binary tree which is possible is something like this. So we can have a left child and we can have a right child. Along with that, of course, both the childs. Now, pretty sure that you must have learned about binary trees in the module as well as what exactly height is. How do we define the height? Now, next can be height equals 3. For this particular height, we can have many binary trees. So let's say something like this. This is having height 2. Now we can have this. Similarly, this is also a binary tree with height 3, right? So there are actually many possible for height 3. We will not be able to draw all of them. And the answer comes out to be 15. Now at this point, since the question is clear, I want all of you to just pause the video once and think that what exactly can be the approach. Brute force, recursion, iteration, any approach which you are able to think to get to our answer. Like how can we find the answer if we have a question given like this? Great. So I guess many of you must have thought about the answer. Now the very first intuition which most students guess for this particular question is something like this. So let's say we have a tree here. Let us consider the tree for, let me move it, yeah, height 3. What we can do here is we have this tree with a height 2. Now we have at this particular level, we can have 4 nodes, right? So 1, 2, 3 and 4. Now there what we can do is we can take different combination of these nodes, right? So different combination when these nodes will be present or not in my binary tree. That would give us 2 to the power 4. So 2 to the power 4 are all the combination. If we are taking any one of them, all 4 of them, none of them, these are all the combination which we have in front of us. Now we have to subtract 1 here. The reason is that in the case when none of these nodes will be present, the height will become 2, right? Just like this tree where I don't have any nodes present. Okay, so the answer which I get in this particular case is, yeah, so answer is 50, which seems to be the right answer. Now let us try this on, let's say, for a single node as well, for a height 2 as well. For a height 2, this is our one node. Now I will be taking different combination of nodes at this level, which will give me 2 to the power 2 minus 1. And that will be 4 minus 1 equals 3. So seems like this is also giving us the right answer. So we, 1 minute, yeah. So we saw that how here the answer was coming out to be 3. Here it is coming out to be 15. And we are able to get the answer for this particular, with this particular approach. Now let us try to see if this particular approach, it can fail somewhere as well. Let us again draw the tree for height 3 first. Okay. So this is one tree which we have for height 3. Now for height 4. Okay. So let me write it here for height 2. For height 4, we will say that, okay, I have now these 8 places, right? 8 places. So 2 to the power 8 minus 1. That should be our answer, right? Because all I'm doing is with the approach which I thought of, I am just taking all the combinations when my node can be there to make the height tree, to make the height 4. This comes out somewhere to be 256 minus 1 equals 255, which unfortunately is the wrong answer. If our height is 4, this is not the answer which we should get. Answer is somewhere between 3, if I remember it right, it was somewhere around 343 or something, or 315, I guess. Yeah, 315 was the answer. Okay, so we will check that as well when we write the code. So let's see what we are missing out here, everyone. The problem is that yes, we are able to make binary trees which are balanced and with a given height. We are missing out on some cases. One of the case which we are missing out is something like this. So I have a tree. This makes the height 3, and this particular tree, it is having the height 4 and it is balanced as well. So the problem is we are assuming that tree with h minus 1 height will be complete. So that is the problem in this particular approach. Here we are assuming that tree with this h minus 1 height will be complete. That was something which we saw here as well, right? This is a complete binary tree, and now we were trying to add the nodes here. Although this will give us many answers, we will still lose out on cases like this, where this one is not complete and still the tree is completely balanced. Right, everyone? So again, remember, in the question it is given and asked to create a tree which is balanced. Okay, number of possible binary tree. Let me write that as well. Possible balanced binary tree. Okay, so in the question as well, you will see the same thing. What was balance? The height difference should not be greater than 1. Okay, great. Now let us try to think. Now I am pretty sure many of you might have the idea how to do it. So let us go to the new page and see how exactly can we solve it. In trees question, we always make sure that we are thinking like a tree in this manner, right? So this is how we used to think about our tree. Now in this particular tree, if you think, let's say I want the height to be h. Okay, what are the different heights which my left and right subtree can have if I want it to be balanced as well? Okay, and balanced. Here I feel that the first height can be h minus 1 and h minus 1. So the left one can have h minus 1 height and the right one can also have h minus 1 height. Okay, so again, see, whenever we are trying to solve these questions, always try to think that how you can break your problems in such a way that it is a sub problem. Okay, now by thinking around like a tree and a subtree structure, I am able to ask my recursion that, hey, can you give me for h minus 1? Then I will try to form for my h. Okay, great. Other can be, if the height here is h minus 1, then I think it can have a h minus 2 height as well, as still balanced, because difference is less than equal to 1. Similarly, this can have h minus 2 if this has a h minus 1 height. So all I have to do here in this particular question, I can just ask my recursion that, hey, get me the h minus 1, okay, and get me the h minus 2. Once I get these answer from my recursion, all I have to do for my answer, okay, let me write it down in green. I can just directly say that my answer is going to be something like this. So I'm assuming this to be h1. h1 into h1, okay, the first one, that is the first, plus 2 into h1 into h2, right? So this will give your full answer for this question, because we have now worked around all the combination which are present. I hope the same is possible, same is understandable, everyone. Let me quickly help you revise what exactly happened, because this is a little different question than the one you have solved for trees. The question asked us to tell the count. Okay, tell the count number of possible balanced binary tree with given height. We drew it for h1, h2 and h3. Okay, we saw that okay, how many trees are possible. Based on this understanding, I discussed what is the major intuition which most students have, that let's say we have these nodes and I just need to have different combination of these nodes, which is coming out to be 2 to the power 4. And of course, we have to subtract 1 for the case when none of these nodes will be present. Similarly, this seems to work for h2 when height is 2. When we move to h equals 4, this kind of start giving us an error. The problem is that we have missed out on some cases, and the cases were something like these. Okay, so again, we have to make sure that we are overall considering each and every case and making the balanced binary tree. Great. Now, with this approach not working for us, we just went down to our basics and started thinking that about our tree in this manner, the way we used to think when we solved our problem. The constraints are that given the height h and that it is balanced, okay, we have to tell what will be the height that these subtrees can have. Now, if I have to keep them balanced, either they can have the same height or they can have the height difference maximum equal to 1. And if it is given that the whole tree has a height of h, then of course it can be just h minus 1 or h minus 2, so that the difference doesn't become greater than 1. Okay, so pretty sure that now this is a lot clear, everyone. Now what I want all of you to do in your coding exercise, please make sure that you try out this question. You have to make sure to solve the question by first writing the recursion code. Then let's memorize that solution. And once the memoized solution is clear, then I'm pretty sure the tabulation or pure DP approach you will be able to write as well. Okay, so great, everyone. Please try out this in the coding exercise and then we are going to discuss it in the next video.